Hello students, welcome to Unit 2 Notes Section 3-4. At this time you can pause the video and do the warm-up on your own. I will be starting in a second to go over it. So classify each angle as acute, right, or obtuse. The first one is going to be a right angle, right? We have our right angle marking there. So right angle. The second one, judging by appearance, it appears to be acute. And the third angle appears to be acute as well, judging by appearance. Okay, so solve each equation. We have 30 plus 90 plus x equals 180. I'm going to combine like terms. So I will have a 120 plus x equals 180. Take away 120 from both sides. And x is equal to 60. Okay, awesome. The next one, we have 55 plus x plus 105, so x plus 160, because when we combine like terms, 105 and 55 is 160. We take 160 away from both sides, and x is 20. All right. The next one, we have x plus 58 equals 90, so I'm just going to take away 58. There's no combining that needs to be done. And so x is equal to, that's 32 degrees, 32, I think, right? So 30 and 50 is 80, and 2 and 8 is another 10, so that gets us our 90 degrees. And lastly, we have this item here. Let me just move this. We have 32 plus x equals 90, so we're going to take 32 away from both sides. And we get x is equal to 58. Now let me ask you, what do they all have in common? And you probably said an x, which was right. What else do they have in common? Respectively, they have something in common, and that is that we're setting everything equal to either 180 or we're setting everything equal to 90. Because remember, straight angles and right angles add up to 90 degrees and 180 degrees, respectively. So this is going to be something we're going to need to work with in in this next lesson. So here we have the triangle angle sum theorem. And with the triangle angle sum theorem, it literally means when you add all the angles together and they equal 180 degrees in a triangle. Okay, so there's going to be triangle work that we do today. There's also going to be parallel lines work that we do. Our objectives are classifying triangles, finding the measure of their angles, and using the exterior angles of triangles. This lesson might be a little bit longer than the last one, but not extremely long. So the first thing we want to do is classify them. And so here we have an acute angle. Here we have an equilateral. What that means is that equilateral triangles are also equiangular because they have three congruent sides. Here, equiangular have three congruent angles. So in this case, all the sides are the same length and all of the angles are the same length. Then we have other classifications. So I like to put kind of like a separator right here. I like to put a separator right here between the two. Now in the next one, we're able to identify them as both by their angle measure, okay, by their angle measure, so acute, right, or obtuse, but also by their side lengths, isosceles and scalene. Now, all equilateral triangles are acute. All equiangular triangles are acute. And the reason why is because they all have to add up to 60 degrees. Both of them are the same. They both add up to 60. So 60 is an acute triangle. Now, when we classify by its name, when we say, hey, this is an acute triangle, that is because all the angles are acute. So in almost all triangles, we have a lot, I'm not going to say almost all. Most triangles have, in most triangles, the angles are acute. In only certain cases do they have one right angle or do they have one obtuse angle. And that's what justifies them. That's what changes their classification from being acute with 3 acute angles to being a right one that has 1 right and 2 acute, or 1 obtuse and 2 acute. So that overrides its name. So 1 obtuse angle, you have an obtuse triangle. A right angle, you have a right triangle. All acute is acute. Its sides can be either isosceles or scalene, and isosceles means that 2 of the sides are congruent. Scalene means that none of the sides are congruent. Again, if 3 sides are congruent, you have an equilateral or an equiangular triangle. All right, so, here's some vocab. We'll go through all of that right now. Did I put a slide in anywhere with those? I did. Do I want to go out of order? Yeah, this slide really should be in a different spot, but if you can please move over to this slide, I think it would make sense at this point. So in all of these, we're going to classify them. So this one is pretty easy, this first one. It looks to be acute and scalene, because there's no markings to say that, hey, some of these are the same sides, some of these sides are the same length, or some of these angles are the same length. All right. Now this next one looks like it's a right triangle that has 2 congruent sides. So this is a right isosceles triangle. Isosceles. That doesn't look like an E. That still doesn't look like an E. Isosceles triangle. Isosceles. Isosceles. Yep. Okay. That is a right isosceles. Okay. This next one, it appears to be similar, but smaller. So this one is an acute, and it's going to be isosceles because it has 2 congruent sides. And from those 2 congruent sides, we also have 2 congruent base angles. Boom, look at that. Right across from them are some congruent base angles. Right, the next one appears to be equiangular and equilateral. So we can say an equiangular equilateral. We normally just call it equilateral. We don't really reference its angle measures most of the time. Equiangular, EQUI angular, EQUI ANG angular, equilateral. Okay, good. This next one appears to be an obtuse isosceles. Obtuse isosceles. And we're getting there. This top one appears to be an obtuse because of that one obtuse angle. So obtuse scalene. No sides in common. And the last one is a right a right scaling. And it looks like it went through all of them. I had acute scaling, I had right scaling, I had obtuse scaling. I had acute isosceles, I had right isosceles, I had obtuse isosceles. And then I had my equiangular equilateral. All right. Determine which of the following triangles can exist. Acute scaling is a yes, right? It's right above here. I have a right equilateral. No, that can't. It can only be an equiangular equilateral. Obtuse isosceles. Obtuse isosceles is a yes. Right scaling is a yes. Acute equilateral. Yeah, it can. We don't really refer to it, yes, but we are normally more specific. Equiangular. And obtuse equilateral is a definite no. Okay, so that was that. If we can go back up to this slide, this is where the rest of the lesson should take place. And I don't know why they go out of order, but whatever. I would have done a different order, and I probably should have. So in this case, we have the triangle angle sum theorem. That means it says the sum of the measures of the angles of a triangle is 180 degrees. What does that mean? Measure of angle A plus measure of angle B plus measure of angle C equals 180. That is a theorem. It can be proven. And here's a little proof down here. If you were to take angles 3 and 2 off, if you were to tear them off, and you put them here, you would actually have a straight line, making it 180 degrees. So that's your little paper proof of why they add up to 180, because you have a straight line, you have angle 1, you have angle 2 and 3. So, well, I mean, you have angle 2 and 3 that are this plus this other top angle for this triangle, add up to 180. And because of that, check this out. Because 2 and 3, you tear them off and you put them right here, that's also equal to this outside line here, which we call an exterior angle. So what is an exterior angle? It's when you continue the triangle on as a straight line, and that exterior angle, which you see here, is equivalent to the remote interior angle. So in this case, 1 is equal. It's equal to the sum of 2 and 3. That's your visual. 2 and 3 is there. 1 is here. They add up to 2 and 3. 1 adds up to 2 and 3. Okay, so same thing here. If I were to just continue this line, oh wait, I did the wrong way. Sorry. I mean, it doesn't really matter, but I'll do kind of like a wind turbine here. So I'll put angle 4. I'll do 4 for that, and then I'll do 5, and I'll put number 6 right here. So measure of angle 1 is equal to measure of angle 2 and 3. And then what else could I say? I could say measure of angle 4 is equal to the measure of angle 3 plus the measure of angle 6. What else can I say? Well, the measure of angle 5 is equal to the measure of angle 2 plus the measure of angle 6. So there's not just one exterior angle, there's actually 6 of them. Think about now if I do the other way, and I'm not gonna get crazy here. I'm not gonna keep going, but you have this exterior angle, you have this exterior angle, and you have this exterior angle. So there's really 6 exterior angles. And again, they are equal to, the exterior angle is equal to the 2 remote interior. How do you know which ones are remote interior? How did I know which ones to pick? Well, listen, 4 is attached to 2. So cover them up. If you're looking at 4, cover it up and cover 2 up. What else is inside the triangle? 3 and 6. Okay, so that's the ones that matched up with 4. What about 5? Cover up 5, cover up 3. Well, 2 and 6 are in the interior, so 2 and 6 are the remote interior. Okay, cover up 1, cover up 6. 2 and 3, which were the initial example, those are the ones that match up, okay? So it's really just based on the visual. So that explains it's also, they refer to it as the 2 non-adjacent interior angles. Yeah, so that is adjacent. 4 and 2 are adjacent. Therefore, 6 and 3 are the non-adjacent interior angles, making them remote interior. So hopefully I explained the vocabulary enough. Let's go down to this next problem here. Use a triangle angle sum theorem to find the value of x, y, and z. Okay, so this one is a triangle angle sum theorem. This is not the exterior angle, so I'm just going to use what I know about a triangle. I know a triangle has 180 degrees. So let me look at triangle 1 right here. For triangle 1, I think I can find x. If I do 65 degrees plus 39 degrees plus x degrees equals 180, I can actually solve for x in that triangle, in triangle 1. So I'm going to combine like terms. Oh, by the way, this is kind of like our warm-up that we just did, right? 30 plus 90 plus x, something like that. So I'm going to combine like terms. So 60, 70, 80, 90, 104 degrees plus x degrees equals 180 degrees. Take away 104. I get x equals 76 degrees. And so now I have 76 degrees right here. And now this triangle has 2 variables. Oops, this one has 2 variables, so this is difficult. You know what I can do? I can use this straight line, knowing that it's 180, to find y. I could say, oh wait, y is actually an exterior angle to 39 to 65, right? That's another option. So again, it's going to be the difference of 180 and 76. So that's another way. I could also find z by doing this outside triangle here, right? So this angle combined is an angle, this angle, and this angle all have to add up to 180. So I could literally do that to find, oh, so let me put 76 down here. There's just so many ways to answer this. So I got to start with one of them. So let me do 65 degrees plus 39 degrees plus 21 degrees plus z degrees is equal to 180 degrees. What I'm doing is this angle and these two combined are equal to, when we add them together, and z, we will get 180. So I'm going to combine like terms. So 60, 70, 80, 90, 100, 110, 9 and 1 is 120, 125 degrees plus z degrees equals 180 degrees. So I'm going to take away 125. So z degrees equals 55 degrees. And let me just check my work real quick. So 55 and 65 would be 120. And then we have 130, 140, 150, 160, 170, and then 9 and 1 is 10, which makes it 180. So that is good. Right, so this one is 55 degrees. That is one way of doing it. And then you know what? I am, just for the heck of it, going to do the exterior angle theorem with y. Nope, I missed some of it. I'm just moving it around so I have some room. For y, I'm going to say that the two remote interior angles are 65 degrees and 39 degrees. Why not? And that is equal to y degrees, because y is on the remote exterior. Is on the exterior, and the two remote interior angles are 39 and 56. Now you'll notice it's the same thing. I'm going to do this one in a couple ways. So that's 60, 70, 80, 90, 104 degrees is equal to y degrees, is equal to y. So 104 degrees is y degrees. All right, what else could I have done? Well, I could have just done, or I could have said, you know what, 180 take away 76 is 104, because it's a straight line. And so they have to be supplementary. So that's another method. Or I could have done, so I did that one, I did that one. Once I have 21 and 55, I could have done 21 plus 55 degrees plus y degrees equals 180. And guess what? I would have gotten 50, 60, 70, 6 degrees. I would have gotten, give me one sec, I'm getting lazy here. 21 degrees plus 55 degrees plus y degrees equals 180 degrees. So 50, 76 degrees plus y degrees equals 180 degrees. Take away 76. And we get y degrees equals 104 degrees. There are so many ways I could answer this problem. You're not restricted to one. So I gave you all the tools in your toolbox. You just got to figure out which one you want to use. Okay? All right. Going on to we did this slide already. So we will now going on to the exterior angle theorem. So in the exterior angle theorem, remember the exterior angle is equivalent to the sum of the two remote interior angles. So in this case, the measure of angle 1 is equal to 40 degrees plus 30 degrees. So the measure of angle 1 is equal to 70 degrees. Even if you do not trust me and you're like, I don't believe that, I don't believe any geometry book that has that theorem. Okay, well, listen, there's other ways to solve for that 70. Think about this. 180 take away 40 and take away 30 is 110 degrees. That would be this angle right here. And then what's 180? Now that it's a straight line, take away 110 and we get 70 degrees. So you don't have any other option but for that to be 70 degrees. So that's just one of the ways to do it. Okay? But here's where it's helpful. What if you don't have this angle but you have this one? Well, instead of finding this angle using the fact that they're supplementary because it's a straight line and they add up to 180, finding this angle and then adding these two and finding this one when taking away from 180, that's kind of a lot of work. What we could just say is that 113 degrees is equal to 70 degrees plus the measure of angle 2. So if I add to the two remote interior angles, that is going to be equal to the exterior angle. So then I just take away 70 from both sides, and 11 minus 7 is 4, so 43 degrees is equal to the measure of angle 2. So it just saves us a little bit of time when we actually use the triangle exterior angle theorem in the right way. All right. Two angles of a triangle measure 45 degrees. Find the measure of an exterior angle at each vertex. So in this case, we're going to have to draw this one out a little bit. So let me draw I'm going to draw a right triangle, because a right triangle, I wonder if it will let me draw, yeah, it should. I mean, that pretty much looks like a right triangle. Let's assume it was. I'm going to label this 45 degrees and 45 degrees. That would leave this to be 90 degrees. And it says, find the measure of an exterior angle at each vertex. So I can do the exterior angle either direction I want to, but I'll go this way. For this one, again, I could go this way. It's not going to matter. All right, because you see those vertical angles. It doesn't matter. This angle will be congruent to that one. So either one I choose, it won't matter. But I'll go up and I will go off to the side just to make it easy to see. And so the question is, what is, let's call this angle 1. And I'll call that angle 2. So angle 1, the measure of angle 1 is going to be equal to 45 degrees plus 90 degrees. So the measure of angle 1 is equal to 135 degrees. And guess what? Same thing's going to happen for angle 2. So I'm literally going to paste angle 2 right there. Because it's the same thing. You know what? I'll change the color. Okay. I'll change the color of this. And that. Okay. And so those are the measures of the exterior angles. Okay, we are getting close to the end. There's your notes. We'll do these in class, but let's try to finish this with one last example. So the lounge chair has different settings that change the angles formed by its parts. Suppose that the measure of angle 2 is 32 degrees. This is very hard to see. Let's see if I can come up with a better color. 32 degrees. There we go. And measure of angle 3 is 81 degrees. Find the measure of angle 1. So the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. So the measure of angle 1 is equal to 32 degrees plus 81 degrees. So the measure of angle 1 is equal to 30, and 80 is 110, so 113 degrees. So the answer is 113 degrees. And so now we're going to change the lounge chair so that the measure of angle 2 is 33 and the measure of angle 3 is 97. Find the new measure of angle 1. So I can literally use all of this. Whoops. I will change that. So instead of, what is it, 33 and 97, we have 33 and 97, which ends up becoming a 90, 130 degrees. And the last part, 130 degrees. Okay, the last part, explain how you can find the measure of angle 1 without using the exterior angle theorem. You can use a straight angle to find the value of the third angle in the triangle. Oh, explain how you can find the measure of 1. I'm sorry. You can, first, you can find the third angle of a triangle. Oh, let's cut this. You can use the triangle angle sum theorem to find the third angle of a triangle. Then we can use a straight angle which is 180 degrees to solve for the measure of angle 1. Right? So we're going to just do 180 take away 33 take away 97. You'll get 50, and then 180 minus 50 is 1. So that's just one of the strategies we can use. Okay, I think the video has been long enough, so we will start these notes in class tomorrow. All right, but good luck with your CUDA. Your, not your CUDA worksheet, your, good luck with your IXL work. Thanks.